So far you've seen what the problems can be. So Andre was talking about what can be done on one side. Before him, there was a discussion on what problems you can run into, and RPKI can be one of the tools you can use to overcome those problems. So before I start, how many of you have ROAs already? Oh, that's depressing. Okay, we give courses on how to create them. The RPCC gives them for free. So please, please, please. So here it is. RPKI and how it works. Looks pretty complicated, doesn't it? Okay, let's split it up. RIRs, validators, blah, blah, blah. Simply put, 3 steps, 3 parts. We have, you can create certificates. And what do the certificates contain? What do the ROAs contain? Root origin authorization. They contain information on your network, on a network that you are managing, on a network that you received from the RPCC, the size of that network, the subnet, the maximum size of the announcement, and the AS number that's supposed to be originating it. That piece of information put there on a repository, in this case, in our region, on our servers, on the RPCC servers. We manage that for you completely. We'll see in a moment, it takes a few clicks to just create it. And from that, we sign it, we create a chain of trust, and then you install and run a validator. Validator is a piece of software, we'll see also that in a moment, that you use to download all these pieces of information, all these ROAs, and check if they're valid or not, if they fulfill the chain of trust, if they can still be used or not. And then, last step, that's something that at present, as you could see in the room, we don't have many people who have ROAs, who have certificates. Certificate validation can be done already, but it doesn't give you good results at the moment, because in a perfect world, everybody would have a ROA, everybody would have a certificate, everybody would have a piece of information stored somewhere that says this AS number is supposed to be originating this network up to this size. The announcement should be like this. And we could create a router configuration that takes this into account, that looks into the ROAs as well, which come from a chain of trust, which validated. We look into the ROAs. Our router takes that piece of information, looks into what can be certified, what can be validated there, and with that we take routing decisions. So here it's simply put. First piece, the RIRs, regional registries. They handed out IP addresses to you. They can somehow certify that you are the holder of that resource. Second piece, validator. Validator is a software that you run on your own machine. You download all the information that you get from the RIRs. You mangle it a bit, and then you put the validator to talk to a router, to your routers, so that you can build configurations based on what you get from all the informations you get from the RIRs. How many of you filter based on the root objects you find in our database, in the RIPE database? Show me your hands. I can't see them from here. So, okay, quite a bit. But so let's take a look, a deeper look. Creating a ROA. This is just the interface you find in the LIR portal. And again, how many of you have an LIR portal account? RIPE NCC. Ah, now I see some hands. Have you ever noticed the certification tab in the LAR portal? If you go in there and you just click on the suggestions you just look at the suggestions that we give you, you can just create a ROA. It doesn't harm you, don't worry. Nothing bad's going to happen. What's going to happen is that somehow, somewhere, on the RIPE-NCC servers, you will have a piece of information that says, these are my networks, and I'm supposed to be originating them from these AS number. That's most likely, in the suggestions we give you, is the AS number that we assigned to you some time ago. So in that case, you would have your ROAs, and they would be created. Nobody's going to be harmed by that, and the information stays there. Everything is managed by the RIPE-NCC. You don't have to bother about certificates. You don't have to bother about anything. We do that for you. This is the first step. It takes 3 minutes. You just log into the LAR portal, and you can do it right off. Second step is the validator. Validator, actually, there's one software in the world that does this. It's from the RIPE-NCC. But what I was told the other week by our colleague who, maybe you've heard about him, Alex Bond, who worked on it, it was actually born as an internal project to see how we could use the data that we got from the ROAs that people were creating on the on the RIPE-NCC's infrastructure. Turns out that that's the only one available right now. There's no other. But the validator works. It's based on Java, needs rsync on your server, and you run it locally. What does the validator do? Connects to our servers using rsync, downloads all the certificates and builds and tries to validate the chain of trust for all the ROAs and see if they are okay or not. So it builds what's called a validated cache. So you have a locally running software in your network that contains all the information from the ROAs, from all the RIRs actually. If you look at the validator, when it runs, downloads everything. Downloads everything from all the 5 RIRs and hands them off to you. It runs standalone, and basically you download it, you run, there's a shell script that's distributed with it that just starts the software, and it just works. After you've done this, what you have is just something running in your network. And what do you need then? You need to validate the prefixes that you receive at that point. Now, this is not doable right now, unfortunately. And the reason is that, well, you can do that, you can do it, but the reason it's not 100% worth doing so is that not 100% of the resources out there have a ROA. What does a ROA contain? I said it 5 minutes ago. What kind of information does it contain? It's 3 pieces of information. Prefix. Sorry? Originating AS number and maximum size of announcement. So that tells me who's supposed to be originating something. It's like a root object on steroids, basically. So when I have a ROA, I can say, okay, I can talk to my validator and say, validator, I have these announcements. I received this new prefix from BGP. Can you tell me if you have a ROA for it? I look at the ROA. Okay, I look at the ROA. When I get the ROA, I look at the prefix size. I look at the originating AS. I look at the max size. If they all match, then I can accept it. I can build my filter and say, well, it's completely valid. Perfect. If I get an announcement that has good originating AS, good prefix, but different max size, the size of my announcement is out of the maximum size I have in my ROA, then that's deemed invalid. And I can take different routing decisions based on that. I can write some parts in my configuration that say, do something different. Give it a different local preference. We'll see that in a second. And then if I ask my validator to give me a ROA for a specific prefix, and there's no ROA for it, it gets into unknown status. I don't know, there's nothing matches it. So the reason is now around 90% of the prefixes we see in the routing table have an unknown status. So there's not much difference in what we would see if we were to filter based on this. But how does it work? How does this work? How can I do that? First off, where is it supported? Pretty much every vendor has support for it. Even Quagga or Bird has preliminary support. But all the vendors have it. And I have two examples. One is with Cisco, one is with Juniper. This comes from, we have a test bed at the RIPE-NCC. It's actually, there's a router where you can log in freely. We have a 7200 in the offices where you can log in and test and play with RPKI and check how it works. So as you can see here, the three statuses that I mentioned earlier, you can see them here. Invalid, if I build a route map that matches if RPKI is invalid. So if I have something that's different from what I have in the ROAs, I receive the announcement. I look into here, prefix is invalid. So there's a ROA that has different information from what I have. Then I can give it a different local preference. And the same I can do for not found, which is unknown as a status. And if I have that, I can just set normal local preference. And then I can do something different if my prefix is completely valid. So I can build based on what I get from RPKI. And this is how I apply it in the neighbor configuration. So I just apply that as a route map, as you may know. And I just define my RPKI server, which in my case is going to be my validator running in my network. So I can run it wherever I want. Juniper. Juniper, again, I just look at the valid, then I can take different decisions. So I look into my create a policy statement. There you go. I do the same for invalid and quickly in unknown. So I just modify it, just modify my configuration depending on what I get from the ROAs. And here is how I configure route validation from my neighbors here. So far, we've talked about routing incidents, and for all the people who spoke before me, we were all talking about different kinds of routing incidents. The vendor presentation before the break, they were mentioning incidents where the AS path changed. In this case, RPKI would not work, would not prevent that from happening, because I wouldn't check the path in between. So this is one of the limitations of RPKI, and this is the reason why there's BGPSEC coming in. That was already mentioned by Andrei before me, where you add another layer of complexity. You add another layer in between, and basically you use signatures in the AS path to verify whatever is in the middle. But that adds also a lot of CPU cycles for every router. That adds a lot of work for all the devices involved in the chain. So while RPKI is a little more gentle on you, BGPSEC adds a lot more security with a lot more CPU cycles, though. So I hope I was quick enough for you, didn't make you fall asleep. Do you have any questions? Yeah.
We do from Richard Clayton.
Could you say something about how this works with the other RIRs? Because at the moment we're seeing a big problem with unused space being turned into ripe route objects because all of the people who stuck up their hand and said we filter on this, so the bad guys have to get these things into route objects. I've been documenting this. RIPE is hopefully doing something about it. How is that going to be better in this certificated world?
You mean route objects against RPKI?
Well, basically, how are you going to do sign certificates and create certificates securely when some of the resources are coming from other RIRs? Yeah. And sometimes the ASs belong to other RIRs, sometimes the prefixes belong to other RIRs.
Yeah. So that is not possible at the moment. So what you can do now in the database, for example, for creating a route object, where you can use the RPSL maintainer for creating an AS number from outside region in the RIPE database, for example. That's not possible at the moment in RPKI because the idea is that the whole chain should be certified. I don't know the work that's going to be done on that, so I would have to ask colleagues about that. But the other part, the first part of your question was also about other RIRs. The situation in the RIPE NCC in the region here is that we have in total numbers more ROAs than all the other RIRs. In percentage, LACNIC is higher than we are because they are doing a lot more promotion than we do. But what I also have to say is that as I mentioned already, the interface is so easy that you can just go and create the ROAs for your resources on the LAR portal. And it really takes 3 minutes. So I hope I answered your questions. Okay.
You said the limitation on validation was that there weren't 100% of ROAs available.
Yeah.
Why would you not simply create every combination of ASN and IP block? RIPE already know what all my ASNs are and what all my IP blocks are. Just make a matrix and it's done.
Yeah, I think we would end up with a very high number of ROAs to be checked. And I don't know how much your validators would like that, because then your validators would have to create, to manage this whole cache by themselves. I think that's something that we took into account because I remember hearing about that, but for the moment, no. Because also, imagine that there can be parts of address space that you are holding at the moment that you subassigned or suballocated to somebody else, and that person, that entity, also has an AS number. So they are announcing it by themselves without the RIPE NCC knowing. That's totally plausible, that's totally doable. So that would make those people could be considered, those resources be considered invalid by the ROAs in that case. So we would have a case where something is done completely in a clear way, but by the ROAs that we created using this matrix would not. So it might be something to ask my colleagues and see if it would be doable again. But yeah, I will report that. Okay.
Hi, can I add something? Andrew Wolski, RIPE NCC. I just want to say that RIPE NCC is not a routing police, and it's really far from that. You have to make your own routing decisions. What are you going to announce and how? And those BGP relationships, like I can validate on my peering, right, which is a private peering. And I would like that because my peering partner can tell me whatever he wants, right? So I want to filter that as well. So it's up to the operator to make the decision what he's going to be routing and what he's going to be announcing. Because if we're going to create it for every possible kind of situation for you, I mean, if somebody will deaggregate your, will announce a less specific, right? And we'll, you know, because we are doing that with some kind of automation, would cover that as a raw, we would defeat the purpose. So we give you a tool, you do whatever you want with the tool, right? That's the whole idea.
Okay. Well, thank you very much.